Hi Year 12s, I'm back for another instalment. This is exercise 3c, question 7 part E. We have our function f of x equals cos x minus sin x, and the aim here is to find stationary points so that we can draw a sketch of this function. Okay, so we need the derivative to find the stationary points, f prime x. Okay, derivative of cos minus sine, and derivative of sine is cos. Derivative of sine of x is cos of x. So there is our derivative. To find stationary points, you need to make this equal to 0, because this is our gradient function, and stationary points occur when the gradient equals 0. So our derivative will equal 0 when, maybe we write sine x equals minus cos x. We could do that. Now I'm seeing a situation here where we could do a sine divide a cos. If I divide this by cos of x and divide this by cos of x, right? So your course doesn't involve a lot of trig identities, but there are two that you should always have in the back of your mind, I think, and they are the Pythagorean, right? The Pythagorean, as in right-angled triangle, and we say sine squared, the sum of the squares of the two shorter sides of a right-angled triangle is equal to the square of the longer side. And given SOHCAHTOA, SOHCAHTOA, where tan is the opposite on the adjacent, right? Opposite, adjacent, let's put in a little angle, right? Opposite to theta, adjacent to theta, right? So by definition, if tan is the ratio of that opposite length divided by that adjacent length, then tan is sine divide cos. Okay, so that's what I'm setting up here. So f of x will equal 0 when tan of x equals cos divide cos minus 1, right? And I'm going to make some room because I like to draw circles, right? The unit circle is going to be quite useful. By the way, I could have just thought about this top bit, sine of x equal minusing cos of x. I think I can still find the solutions on the unit circle fairly easily. All right, there we go. Perfect potato circle, potato-shaped circle. I'm using a stylus, which sounds easy, doesn't it? Well, you know. Okay, let's just think about quadrant 1. Right, 30 degrees or pi on 6, 45 degrees or pi on 4, 60 degrees, or pi on 3. So we've got cos is half, sine is root 3 on 2, for pi on 3. For pi on 4 or 45 degrees, we have 1 on root 2, comma 1 on root 2. And in here, where I haven't left enough room, I'll write it out here. 30 degrees or pi on 6. Because we're doing calculus, we are sticking to radians. So you want to start being able to think in radians as much as possible. This is pi on 6. The cos value there is root 3 on 2. And the sine value is a half. And maybe just to complete the first quadrant, I'll whack in a little cos is 0, sine's 1 there. Okay. Now based on this, can I see any values where the sine of x, right, if I put in the same x, remember x is the angle, so some angle here, where I do the sine, I get a value, and then I do the cos, and I get minus of that value, and I'm looking here, guys. Yeah, this doesn't fit, but it's pretty close. Just missing a minus, right? But if I went round the circle, what do we got here? That's 45 degrees, okay, or 3 pi on 4, exactly. Drawn perfectly. We've got minus 1 on root 2 for our x, or our cos, and we've got 1 on root 2 for our sine, and that would fit these conditions here, okay. Here in this quadrant, both sine and cos are negative, but through here, there we go, perfectly straight. The x-coordinate, or the cos, is 1 on root 2, and the sine, or the y-coordinate, is minus 1 on root 2. And that would fit our conditions for when f prime x equals 0. That's when sine of x is minus cos x. Or I could say when cos x is minus sine of x, right? You could think about it with tan as well. All right, tan in a unit circle, it's giving us the gradient of this line, and the gradient here is minus 1, and that's minus 1 there as well. All right, now if I was to draw this, maybe try and draw this triangle coming down to the x-axis. All right, we're saying, all right, we've got from here all the way around was a 3 pi on 4 angle, okay. Inside would be a pi on 4. Our y-coordinate there is 1 on root 2, and our x-coordinate is minus 1 on root 2. Okay. And if I was to then do the opposite, divide the adjacent, I would get minus 1. It's that. How many of those divide, right? That divide, that equals minus 1. It's also representing the gradient, because we've got a change in y, or a distance of y over a distance of x. Okay, so it's like the steepness of this line. And over here you would get the same thing, right, in that triangle there. Okay, so we found our x's. Our x's are 3 pi on 4, and over here, let me do this in a different color. Start here, we're going to go all the way around to the other solution. What angle is that? That's a 7 pi on 4, right? 7 pi on 4. Okay. Now this video is starting to get a bit long, so I'm going to pause it. We'll come back, we'll do the sine diagram, then we'll do the sketch.